All right, folks, we are back live in Redmond. This is no joke live. I'm Dan Fernandez. This is the Q&A section. So before I introduce my esteemed guests here, just remember to send to pound or hash CH9 live, depending on which part of the equator you're on. That's pound or hash CH9 live. Send us your questions. Any questions that you get asked, we have a couple already in the queue, but send us questions about the SDK. And just realize, I don't know if you all can see this, but during our live event, we actually had a big issue. Kinect is hot, and we can't stress that enough. A substation apparently started a fire. You can read about it. This photo is courtesy of Como News. But that might have taken our stream down for just a little bit while we lost power. We were able to gain power again. So apologies for that. But let me just jump right into this. So I'm Dan Fernandez. I'll start maybe this way, and we'll go around. Who would you say you are, and what would you say you do?
I'm Eric Rudolph. I'm on the Microsoft research team. I was working on the NUI runtime part of it and the video capture engine.
Okay.
And skeletal tracking. Sorry.
My name's Bob Heddle. I'm new to the team, and I'm a part of the program management staff, which means that we coordinate the project.
And I'm Carlos Garcia. I'm also a developer in Microsoft Research, and I worked on the audio.
Cool. Cool. Okay, so remember, this is all about Q&A, where you all get to ask questions. We have some questions on here, and we're kind of giggling at this first one just to get it really started. At Will Gucky asks, is it possible to track animals? So who wants to answer that one?
I will answer. Yes, it's possible if they look a lot like a human being.
Okay.
Other than that, no. Just human being shaped objects and things that
Now theoretically, like let's say I want to do the thing that tracks an animal. You know, we shot Carlos earlier, but the thing that, say, you want to get squirrels off your lawn. Yeah. You could do that with just the depth data, right? So somebody has to do that, but all the algorithms and things for that, for skeletal tracking, is really human body parts. We're not tracking animals yet.
Our database is finely tuned for humans, not for anything else. But yeah, you could use the depth camera to track things that are moving in front of your field of vision.
Yeah, so if somebody wants to build the thing to track four-legged animals, so you'll know when your cat is on the keyboard, you can play a loud sound or something as your remote sentry. Feel free to do it and of course contribute, so we can take a look. Next question is at Martin Rojas asks, is gesture recognition part of the Kinect SDK? Who wants to answer that?
Bob?
I mean, yeah, I can answer that. The answer is that there's skeletal tracking part of the SDK. There's no exact, there's no library for gesture recognition, so you'd have to build that on top. And I think we saw a demo that someone did that in the past 24 hours, right?
Yeah. Some people have been doing it. Yeah. And, you know, Arturo's session talked about some of the things, and Ali as well, on what they had been doing for Xbox titles, for ways to do the right kind of gesture recognition, or ways to really interact with the Kinect in more of an application side. So if you haven't yet, definitely check out that session for more details on the best way to do that. And they have a lot of really good tips and tricks in terms of the best ways to do that. But from an API perspective, you get the raw data, and then it's up to you to do that. Is that a fair?
Yep. You get the skeleton at 30 frames a second, and then you have to do processing on top of that.
Okay, great. At Handsaw23 asks, can you have another PC in Kinect to track the speaker and use the extra Kinect microphone instead of the handheld mic? So Carlos, I'm going to look at you for this one, since you are the audio guy, and I'm trying to understand exactly what the question is. Can you have another PC in Kinect to track the speaker and use the extra Kinect microphone instead of the handheld mic?
I'm not sure which handheld mic they're talking about, but I mean, certainly with a single Kinect, you can track the speaker. Use the SDK. It'll give you the position of the speaker, at least a good guess. You could potentially use another one if for some reason you can't use the one.
If I have two Kinects plugged into the same device, can I access the microphone for both of them independently?
Yes, you can connect two Kinects on the same PC and use them independently.
Okay. including the audio stream as well,
Yeah,
right?
so you could potentially have two Kinects in different positions and sort of use the position information for both. I don't know, get better accuracy or something like that.
You know, that's one of the things I haven't seen a lot of audio applications or in the community people doing stuff. So it's going to be kind of interesting to see, because this is kind of the first time you've seen some of the maybe community projects. None of them have really done audio stuff. So I think that we're going to see a lot of cool audio or multimodal applications come out. So and multi audio sounds interesting. At Ivo FlipC5 asks, can the data be posted when processing using multiple Kinects so I can calculate the skeleton movement later on?
So for post-processing, you could. There is currently no way to get post-process data on disk into the Kinect engine to process the skeleton movement, but there have been a lot of requests for it, and we're paying attention to it.
Process. Well, I'm not sure quite what that question means. I mean, if you could certainly write the stream of skeletal information that comes out at 30 frames a second.
I think they mean the depth data.
It's can the data be post-processed when you?
So you can calculate
the
skeletons.
skeleton. I guess you could save. You could also save the depth. You could write the depth image to a file.
Yeah.
And then you could use your own processing, but it would not have the skeleton information at that point.
Well, I got
It almost seems, this is the way I'm interpreting it, and you tell me if you all see this the same way. It's almost like they want to say, hey, I'm going to later give you an image, and then I want you to find the skeletons in that image, or that series of images.
We got a lot of requests for that
That's,
yesterday.
yeah, that's not supported in what's on the in the download right now, right?
Yeah, but we know about that. A lot of people want to do this.
Yep.
So, and speaking of which, so this is a beta. We are about taking feedback from the community. So, if you all have, questions, we're starting to get some in terms of the API as more people use it. Go to the forums. Give us your feedback in terms of what things, whether it's API changes, new APIs, the things that you're looking for, and the kinds of scenarios that you're looking to build, and maybe why, the current APIs don't enable that. Okay, so the next question is at Aaron Ark asked what kind of cables we need to connect to a PC. So the answer is it depends. If you bought a bundle, Xbox 360 Plus bundle, it includes almost like an orange cable that has a small angle on its USB. That cannot be plugged into directly into your PC. It's not a normal USB cable. What you can do is go to the Microsoft Store or go to, say, eBay, and you can buy a special cable. And that special cable plugs into that orange cable and includes a USB cable and a power source. Now, if you bought the standalone Kinect, it already comes with that cable. So if you don't have that cable, and basically the question is whether it has a power source. If your Kinect has a power source plug, then you're okay, because the other part of that power source is a USB cable. Otherwise, you can go to the Microsoft Store, search for Kinect USB, you'll find it, or search for eBay as well. So
definitely the easiest thing is to go buy the standalone box. Then you'll be set, right?
Absolutely, absolutely. Akashu asks, where can I find tutorials for coding in VB? So we do have, I think it's actually in the live stream somewhere in there, and I'm pointing to down there, is a link to the Quick Start videos. So for the Quick Start videos, we have basic camera, depth data, skeletal tracking, and audio, and all the samples we ported over in both C# and VB. So you can see them backwards and forwards, and if you download the samples, all those samples are in VB as well. So they do work, and we also have, now this didn't ship in the SDK, but all the SDK samples, so when you install the SDK, it doesn't include the Visual Basic samples, but we do have all the C# versions translated to Visual Basic. We don't have the C++ versions, but those are, C++ is its own animal, if you will. But we do have those available for download as well. So next question, at Inti Soto asks, do you plan to release Xtweak or similar tools to the developer community? So are we... I'm going to let you comment on this one, because I don't even want to confirm or deny. Or
Yeah, I'm sure that I should know what Xtweak is. I can admit that I don't, but we're really not discussing the plans of what we're going to do in the future. So we're definitely got a bunch of plans, but we're not ready to disclose them.
Okay, okay. And the next question is, at RY Mix, does the Kinect SDK come with a library of standard gesture poses and control methods? So we talked about this, hold hand over menu. This is kind of the tap and hold gesture that you see. The short answer is, I think, no. We did answer that already. I think we have some of our examples that we shipped. There's a really nice Kinect Paint app that was done by some of the guys, Evan Lang and Laurent Bugnon from Identity Mine, that is almost like a nice styled, I'd say, Metro design for a painting application that just has tap and hold buttons. So the idea is I tap and hold to select a certain pen, I do a gesture to start writing, I tap and hold to say close the application, and so forth. So you can reuse that application, and similarly, when we first showed the Kinect SDK, our Jelly Bean, our drivable lounge chair, that also had tap and hold, and basically it's a small animation that goes around and gives the user feedback that they've entered into a button and they need to stay there for, say, 1.5 seconds. So, but that's a very simple control. It's when whatever your cursor is, in this case it may be a mouse, is over the button, start a timer, and then wait 1.5 seconds. If they exit, reset the timer. Otherwise, do some particular action. Consider it a click, if you will. And we do have examples for that. I think that project's jellybean.codeplex.com, and I believe it is paint.codeplex.com that you can download those samples. So next question, at NACNudrium. What is the minimum achievable latency with the skeletal API? I.e., would a live musical instrument be feasible?
This is a great question and the most technical one I've been asked yet. There is no frame latency inherent to the new API. That as soon as a depth frame is captured from the capture pipeline, the skeletal is processed, and it only takes a fraction of a CPU core's full processing speed to process the skeleton. But the depth latency being every 30 frames a second gives you probably a latency that is still sort of unacceptable for real musicians' needs for a live musical application, but it's close. I usually see musicians want like 10 milliseconds or less latency, and we're talking more like 30. So that would be difficult to get a real feel of playing an instrument, but it would get close. Nice question.
Cool.
Maybe you could do an organ. Built-in latency.
Yeah. Now, @DeWitt asks, how much processing power does skeletal tracking take? Could an embedded system handle it? So does anyone know the system requirements off the top of their head? Because I do think you need a pretty decent machine to install, and it is in the README. I just don't know it off the top of my head, so I'm going to put you all on the spot.
This is 2.3 gigahertz processor. I mean, I don't know the minimum machine latency off the top of my head, but we're talking it's a higher end machine that that is spec'd. It certainly depends on what your application is doing with that data. So if your application is doing a bunch of processing, it needs to make sure that you are leaving the headroom to be able to do that, or doing it with threading to make sure that you have one core associated with some of the skeletal processing and then another core associated with your application. I don't know, Eric, you probably have a better answer than that.
I'm not sure. To give you a completely honest answer, my laptop can't keep up with full skeletal processing, but my desktop can. So I think it depends on how much cache your chip has and what kind of floating point instruction processing power you have and the bus speed. And I don't really know what kind of embedded system you would want. I mean, does it have really good floating point? Does it have vector processing stuff? SIMD instructions? I don't know the answer to that.
Yeah, you definitely need a beefy machine in that embedded system.
Yep.
Now, just a quick question on that. Do you, is it kind of a pay-as-you-go approach? So let's say, for example, I just want to see the video frame, or I just want to get depth frame, which is almost just the raw data coming from the sensor. Do I, am I going to need I know skeletal tracking, there's definitely a lot of computation going on, but will I have to, I guess, have more of a performance cost for just those two scenarios, if I'm just getting, say, video or depth?
No, extremely lightweight.
Yeah. Okay.
And no latency.
So in terms of, at least for accessing some of the scenarios, then that may be acceptable. But I really think if it's about skeletal tracking, then there needs to be a lot of, that's where you get your computation hit.
Yeah, very heavy.
Point, yeah.
So @CoolRudsky asks, does the Kinect coding support a more object-oriented approach or procedural approach?
Wow, for the managed APIs, it's definitely object-oriented, and for the native code, it's definitely procedural.
Yeah.
Yeah.
Pretty much sums it up.
Yeah, exactly. Wendy90N asks, is it possible to directly extend the skeleton to track drumsticks or other object, as in to add another joint? Oh, that's an interesting question, or an interesting scenario too.
I would say no, but if you can track the skeleton and you know where the skeleton points are and you map from the skeleton to the depth image, you could do your own processing to figure out what is attached to the skeleton, as long as it doesn't obscure it. So if you have two drumsticks coming off of your hands and it's able to track your hands, you should be able to track where the drumsticks are.
So the idea there is you'd get the skeleton position, know where it is in the depth frame, and then just kind of follow something of similar depth
Yeah, that'd be my first
build the
approach.
outline?
Mm-hmm.
Okay, well, there you go. And you all have to contribute your code now, and of course, give Eric full credit. Ian Scopa asks, can you recommend a good resource for getting started with Visual Basic? I think we talked about this before. I think they're just talking about general programming getting started guide. So MSDN has, so one, we definitely need to continue the pimping out of research.microsoft.com/Kinect SDK. That's where you download the SDK. For getting started with Visual Basic, the best choice is you go to msdn.com/beginner. And there's a series for absolute beginners, and this is explaining programming. There's teach your kids to program content that's really designed to kind of explain what is object-oriented and using kind of examples for non-programmers. And really, a lot of our content documentation, I would say, is built assuming you are a developer. So it'll say, you know, start Visual Studio. You may not know what Visual Studio is or what that requirement is, or a new project or WPF and so forth. So really, msdn.com/beginner is probably your best resource to get started. So keep your questions going, #CH9 live. Now, I do actually have a question for you, Eric, in terms of, you know, this is one of those questions, and it came up yesterday in terms of the supported resolutions for cameras. Because this is, I think there's depth with player index, and video. And hopefully I'm not putting you too much on the spot, but there's specific things you need to know about which resolutions are supported with which. Can you answer that, or am I putting you too much on the spot?
No, it's fine. There's not an easy way to enumerate. There's not an easy way to find out. It's weird. The managed interfaces don't really lend to figuring out what are the supported resolutions for a given image type, but video is definitely 640 by 480 or 1280 by 1024. Depth is 640 by 480 or 320 by 240 or 80 by 60. And depth plus index is 320 by 240 or 80 by 60.
Okay. So, and I think that's why important, if you are combining those two, make sure that you're combining the right sizes, right? Is that definitely something for people to know. How will Microsoft receive feedback from the community about the SDK? So we don't, at a high level, I think we talked about this before, we do actually have the forums. Does anyone remember the URL of the forums, or should we just point them and know that it's linked directly off of that?
Yeah, there's a forums link that's right on that link. So so go there. I don't remember the exact one, but that's easy to remember, easy to find, and we're going to be watching to find the questions that people have, what people are having trouble with, and we'll definitely take that as feedback when we plan our next releases.
Cool. And Eric, you were there last night working late with the Code Camp. What are some of the common questions that you're seeing, people get asked? And I know resolution was one of them.
Resolution, mapping skeletal points to the depth image, then mapping the depth image to the video image. I heard a lot of questions about XNA and getting the video bits into a texture, how to take the skeletal points and map them onto a 3D object to make a 3D object move within an XNA or an OpenGL framework.
Can we dissect some of those? So the first one, there is a method to basically do that mapping, right?
Yes. In managed code, there are methods to map from skeletal to depth and to map from depth to the video feed. But the mapping from depth to video feed only works for the 640 by 480, which is a limitation of the hardware.
640 by 480 of the
video.
RGB image, the color.
Because we save the calibration for the parallax cameras for the 640 by 480.
Okay, and you mentioned the XNA stuff. I know you're not an XNA developer, but was there, were they able to get some of the XNA stuff that they were working on going in terms of loading content into a texture? And I think the other example you mentioned was 3D.
I don't actually know. I didn't stay the whole night. I don't know what they actually got running or not.
Well, we kind of needed you for today, so.
I mean, I think this is where we're at, which is we did not specifically design it for XNA, didn't test with XNA, but we don't see a reason why it shouldn't work with XNA. Is
right.
Pretty much where we're. And I know that we saw some people internally that managed to get it working, but I know they had some hoops they had to jump through, a couple things they needed to figure out. So we obviously need to get more information for those people out there. It can be done, but you might have to be a bit persistent.
Okay.
The other topics I got asked a lot were smoothing the skeletal data. Some people were unaware that we do have skeletal smoothing functions in the managed runtime, and what were good skeletal smoothing parameters. And the other question I got asked quite a bit was synchronization of the skeletal data with the depth and with the video, so that you know exactly where the skeleton is, where the skeleton is compared to the video. And that's actually a hard topic, because the Xbox has definite intervals where things are processed, and on the PC we don't have a vertical blanking interval, and that the streams come out of the capture pipeline with different times on them at different times that are not synchronized, and you have to align the timestamps yourself. So that's kind of an issue that you have to pay more attention to on the PC with this release.
Okay. Yeah, that's definitely good to know. So we have about a couple more minutes here. I did see a question about motor and tilting. I think we answered that before, but just to repeat that, there is built-in API for doing that. I think it's set elevation angle on a NUI camera.
Yes.
And I think it's 27 or 28 degrees up or down, and not something you should be doing often.
Yes. And a bunch of people have asked about the gyroscope or the tilt methods, and we do not do we don't do the gyroscope. So the plane to normal, there's a method of the skeleton, or a data point on the skeleton that describes the vector to the gravity plane, and we cannot return that one right now. And there is a tilt function that also uses the gyroscope method, so that is also out. Being able to move the camera up and down is supported right now.
Okay. So I guess there are some people that have been using the open source libraries and SDK. Have any of you had a chance to play with those, or exposure? Maybe why using the Kinect SDK would be the right choice?
Well, I mean, we love the open source community, and it's great to see the things that people have come up with for the Kinect. I mean, I think it really it highlights how excited people are to use this technology, and that kind of experimentation is just great to see. We developed, Microsoft developed the Kinect, and we think that we have the best view into the technology, and we're the best able to create those drivers and so forth. Also, people should know that the Kinect sensor is just one part of what we consider to be Kinect internally. A huge part, and probably the most, the most amount of research and development went into the software part, and that's some of the technology that went into the skeletal tracking and so forth. So now people can benefit from that technology. It's great.
Awesome. Awesome. Very cool. And one thing I definitely say, and we talked about it a little earlier, was audio. We haven't seen a lot of audio applications, and that's definitely one area where we're going to see a lot. And Eric mentioned some of the transform smoothing, all that algorithms exposed as an API, and having a nice installed and tested driver on my machine. So seeing a red flag is definitely nice. So that is all the time we have in terms of questions. I think we have some of the CodeCamp demoers coming up next. I wanted to thank you, Eric, Carlos, and Bob for being on. And we're going to switch now to our next demo.